Now we have another formula for increment, which is known as Schneider's formula for increment percent, and it is applicable to ring porous trees which produce rings. Suppose we don't have the initial. In Pressler's formula we got to have capital V and small v, means volume at the present age and volume at the preceding age. But here in this formula we have ring porous trees, but we have only the present diameter. This is the inner diameter, and this is the inner diameter, and this is the outer diameter. And and in between we can have the number of annual rings. So we got to have the Pressler borer. We bore into the tree to get a cylinder of wood having the rings. And since n is the number of rings in the outermost centimeter, the increase in diameter will be 2n. Actually, we have to see the last centimeter of the bore, last centimeter. If in the last centimeter we have one or two rings, so in the last centimeter, which can be denoted by n, number of rings, so the growth, then the increase in diameter per year will be 1 upon n. Now here we write the increase in diameter per year is 2 by n, because the growth is recognized not only in diameter is growth in diameter is recognized not only on one side but also on the other side. This also contributes to the increase in diameter. So 1 upon n becomes 2 upon n. That means if d is the present diameter, so indirectly we calculated the preceding diameter. The preceding diameter will be 2 upon n. D minus 2 upon n, because 2 upon n is the growth put on by the tree in 1 year. Now using the Pressler's formula, I told you earlier that when volume is represented in terms of diameter, the formula becomes square. So d square minus d minus 2 upon square means the same thing, where we used capital volume and small v, capital V and small v. So likewise we have the present diameter, which is capital D, and the preceding diameter, which we estimated using using the Bohr method, that is d minus 2 upon n. So this is the formula, part of the Pressler's formula, into 200. Now we don't divide anything here by n, because the time period of increment has been assumed to be 1. Now rearranging the terms, this is a square minus b square, so a plus b into a minus b, and this is a square plus b square, means a square plus b square minus 2ab. So expanding the terms here, we take the 2 common here, we are left with d minus 1 upon n into 2 upon n, and here we take 2 common, it is d, we are left with d square minus 2d upon n plus 2 upon n square into 200. Now we multiply and we with the terms, and we get 4 upon n d minus 1 upon n, and here we divide break this 2 upon n square into 1 upon n square and 1 upon n square. So we are left with the same term in the numerator, and in the denominator what we are going to do is this becomes the formula, this is the formula a minus b ka whole square, and we are left with 1 n square. So this part becomes formula a minus b whole square, and we are also left with the term 1 upon n square. So reworking the formula, we are getting 4 upon n d minus 1 upon n into 2 upon d minus 1 upon n ka square. So here one of the this and square will go, so we are left with 4 upon n, 2 into d minus 1 upon n into 200. So here we have ignored 1 upon n square, which is very small as compared to d minus 1 upon n. So we ignore this 1 upon n square here, and again here 1 upon n, in this term 1 upon n is very small as compared to d. so this can be ignored. So we are left with P is equal to 400 upon ND. This is the formula of Schneider's for estimation of increment percent in ring porous trees, where the only the present reading of diameter is available and not the preceding ones. And increment can also be, represented by using the Pressler's formula. The same way, the quality, current quality and the preceding quality into 200 upon n, and it can also be represented in the terms of price, that is the current price and the preceding price, and the same formula of the Pressler. So that is all about increment percent and Schneider's formula. Thank you.